Today we're going to talk about the Incident Analyzer Smart Map and the wide range of analyses in which it can be deployed to provide an easily understood visualization of the data while it performs real-time analysis. Incident Analyzer performs incident counting, spatial distribution of incidents, identification of repeat occurrences, and visualization of incident concentrations, known as hotspots, and can provide critical information for safety, transportation, infrastructure, emergency response, health, government, and many other commercial uses. Let me just take a moment to talk about the data behind the demonstrations you will see today. The data has been altered. The incident counts have been exaggerated for demonstration purposes. There is also an initial setup to take the data and configure it to generate the information display for the analysis. You can also use local data as a starting point, but you will want to upload it into the cloud so the analysis can be saved and viewed worldwide by anyone you wish to designate. As you may already know, Smart Maps run in the cloud. I just need a subscription to the particular Smart Map that I want to use and browser access to the Map Exchange, the Smart Map storefront, to access them. Let's start with crime analysis. I have incident data for New York City, and it is being processed by the Incident Analyzer Smart Map to calculate hotspots, or areas of high concentration. You're seeing all the data displayed currently, but depending on how I slice it, by interacting with the data, the hotspots will be recalculated based on the visible incidents in my display. For example, I can choose to look at just the grand larceny incidents. Notice that the hotspots now show the grand larceny concentrations. I can zoom in and turn the incident counts on to get an idea of the incident concentrations. I can drill down further by clicking on one of the clusters. It will explode out and show me the detail. If I look around, I'll see that I have a high incident count for 42nd Street in the Times Square area. Enough so that law enforcement would want to look into it further. Addressing that cluster and getting it under control can have a significant impact. As I mentioned earlier, these are not the real incident counts. They've been altered to demonstrate how easily crime concentrations could be visualized and easily detected using the Hexagon Incident Analyzer Smart Map. You can click on any of the active areas to look at a specific situation. For example, how crime statistics vary by day of week or time of day. The ability to look at the data in any number of ways, dynamically, is the key to being able to extract what's important, or gain insight into something that may not have been obvious at first look. Rudy Giuliani, the former mayor of New York City, is widely recognized for having reduced crime during his tenure through the application of what was then called CompStat, or computer statistics. CompStat was essentially a tally of the reported crimes across city precincts in order to identify crime spikes and coordinate a subsequent response. In addition, understanding where the frequency and concentration of crimes were high would enable proactive policing of those areas to make them safer. Resources could be used more effectively. CompStat was credited with a dramatic reduction in crime. At the time, it was a statistical printout, the equivalent of poring over multiple spreadsheets. Why am I telling you this? Incident Analyzer presents a modern-day implementation of this, but with one major advantage. You can also visualize the data and do it dynamically, and drill down to explore the data. Incident Analyzer allows public safety officials to visually inspect their CompStat data and interact with it. Let's move on to another example of the usefulness of Incident Analyzer. In this case, I'm going to use it to look at traffic accident data. For this demonstration, I have traffic incident data for the City of London. With Incident Analyzer, you can dynamically look at the reported data in any number of different ways to be able to fully understand and explore it. I can analyze traffic accidents by road class, day of week, and over a period of time. I can also see from the heat map that Tuesdays, Wednesdays, and Fridays are the worst days for accidents. Again, I want to look for high concentration clusters as a sign of inherent problems causing a high rate of accidents. I have the associated data for the accidents which I can look through for more details. And if I zoom in further, I can see that I have quite a few accidents occurring along Oxford Street, maybe owing to a lot of shoppers converging on the area at certain times. I can prove out whether this is a correct assumption or not by reviewing the data records. With the Incident Analyzer Smart Map, I can get a good understanding of the most problematic areas and gain some unique insights into cause and effect. The information that can be extracted presents a valuable tool to transportation and safety organizations looking to use analytics to make decisions on where to allocate funds. Another really useful feature is the ability to share an analysis with others. I simply give my analysis a name and click the share icon to send an email with the link that captures the current view. I can share this with other registered users, and they will be able to not only see what I am seeing, but explore the data as I have just done. That ends the discussion on accident analysis. But, as they say on late-night television, and that's not all. With Incident Analyzer, I can also look at power outages and response times. For this part of the demonstration, I have outage data for the Harrisburg, Pennsylvania area. Before I get started, I can adjust the hotspot and cluster distance until I get a display that is suitable for my analysis. Casting a wide net will include a wide area in my clusters, or I can go the other way and reduce the area that I want to consider for clustering. For this data set and configuration, I can drill down by priority and view response times for the various types of outages, as well as detect if there are any frequently occurring situations prevalent in a particular area. What I notice here is that as the priority of outage gets higher, the response time drops. That's a good sign. I also notice that near the water, I have an extremely high incidence of outages. I can drill down to see the particular area where they're occurring. From here, I might want to talk to the local field manager or crews to find out why there is such a high volume of outages. Maybe there are some flooding issues caused by proximity to the water and storms in the area. Could be there's a lot of construction, which I would certainly want to verify. Or maybe it's a sign of a deteriorating situation or some other circumstance. In addition, you'll be able to look at temporal slices such as date range, time of day, or work week versus weekends. After you've spent some time with the analysis, you'll be able to gain some unique insights into how best to allocate improvement funding and where to target repairs. Okay, there's time for one more example. The Antiquities Coalition, headquartered in Washington, D.C., is a non-governmental organization working to stop the looting and trafficking of antiquities. To provide a graphical representation of cultural crimes committed by Daesh, also known as ISIS or ISIL, and other extremist organizations in the Middle East and North African region, the Antiquities Coalition partnered with Hexagon to create the Culture Under Threat map. This interactive map displays the destruction of heritage sites in the Middle East and North Africa. It provides unique insights into cultural cleansing that were not previously available through standard GIS maps. The Culture Under Threat map temporally illustrates losses to date with an easy-to-use date slide bar that shows the timeline of the incidents that took place. Unlike previous maps that show a static point in time, the Culture Under Threat map, driven by the Incident Analyzer Smart Map timeline capability, can be used to understand how destruction has evolved across the broader Middle East North African region. The ability to view and analyze this timeline allows for a unique examination of patterns. This allows experts to not only quantify events across a wide region, but provides an opportunity to understand the types of patterns that are occurring, and this can better inform them in the development of solutions to these critical threats. Site info and data regarding the destruction or damage to a site can be crowdsourced. And when pictures are taken at damaged historical sites, the images can be uploaded to the Smart Map so the map becomes an active information exchange and visualization tool. That concludes the demonstration of the Incident Analyzer Smart Map. I've shown you just a small sample of the many applications it has in public safety, transportation, infrastructure, and the Culture Under Threat map. It can also be used for emergency response, health, government, and many other commercial uses. Please visit our website, hexagongeospatial.com, to learn more about smart maps, the map of the future. Thanks for your time, and have a great day.